Hello, my name is Jalen McCaskill, and I'll be presenting today on quantum computing. So, first I'll be going over what exactly quantum computing is, and then I'll be going over each industry that it impacts, including cybersecurity, AI, and medicine. To begin, we have a couple of quantum concepts to go over. The first is bits versus qubits. Classical computers use bits, which are when data is interpreted as a 0 or a 1. Quantum computers use qubits, which are able to interpret data as a 0, a 1, or a combination of both at the same time. And when both are interpreted at the same time, this is called superposition. Next we have entanglement. Entanglement is when two particles are deeply interconnected across two distances. This is very important for quantum computing. Next we have quantum cryptography. Quantum cryptography is the sending of information between two individuals using the laws of quantum physics. So if two individuals were to send data to each other and it was intercepted by someone else, then the two individuals would know immediately, because according to the laws of quantum physics, if a quantum state is observed, then it automatically changes. So both of those individuals would know immediately, and they could send out new quantum encryption keys to secure a secure line of communication. Next we have teleportation. This is not the science fiction teleportation of matter, which physical matter is transferred between a distance, but it is the transfer of a quantum state between two particles across a distance. And this is using entanglement. Lastly, we have dense coding. Dense coding is a process unique to quantum computing, in which a quantum computer is able to transmit 2 bits of data using one single qubit. And this makes quantum computing or quantum computers more efficient in transmitting data compared to a classical computer. Next, we'll talk about cybersecurity. Now, cybersecurity is very important in this regarding this technology, because current computers use RSA and elliptic curve encryption, which is a complex math equation that encrypts your data. Now, a classical computer is not able to crack this encryption very easily. It would take a very long time to crack the data and allow someone to take your information. But quantum computers are able to do this much faster, which is the main risk with this technology. So the main worry within the cybersecurity community is that hackers will harvest data now and then hijack that data later when quantum computers are more available. So this puts a lot of different types of data at risk, including government information, financial transactions, and medical information. All that stuff is at risk. So in the future, quantum-resistant encryption will become very important to protect classical computers from being hacked by quantum computers. Next, we have artificial intelligence. So for AI, computers using AI, quantum computers using AI will be faster. They'll have better data evaluation capabilities, and AI training models will be able to learn much faster than previously before. Now, something very unique to this technology is that quantum computing and AI go hand in hand. They are technologically mutualistic, meaning that one technology also helps the other at the same time. So as quantum computing will help AI to operate faster and give better results, AI could also improve quantum computing by allowing us to create better hardware and reduce the errors from the quantum gates. Next, we have medicine. So the main thing with quantum computing is that we'll be able to simulate drug interactions um, much better than classical computers are able to do. So this will allow us to create new drugs much faster than before. It will allow us to create personalized genetic treatments for individuals, and it will allow us to reduce the amount of outbreaks because we will be able to produce vaccines faster than ever before. So now we'll talk about the limitations of quantum computing. So quantum computing is mainly limited by the quantum noise within a system. So a quantum system is limited by the decoherence of the system. If there are any disturbances in the system, then quantum information can be lost or completely corrupted, meaning the information will be unusable. Our current devices, like the noisy intermediate scale quantum device, is able to use 50 to 100 qubits and is able to do some specialized tasks better than classical computers. But a lot of the information that is received from the quantum computer is completely unusable because there's so much decoherence within the system. So the main research challenge is to create a quantum system with no decoherence so that all the information is usable. Finally, quantum computing is still years away from practical application due to the limitations that were discussed. But it has so many implications to different fields that it's bound to change the way that we live our lives when it is finally perfected. So it's important to keep an eye on this technology and invest in it for the future. Thank you.